Acha. So we want to look into recurrence relation today, and we're going to see that the first three recurrence relation are actually simple. You have to just derive one, and the other two will automatically come up. Okay, so the recurrence relation for Legendre polynomial. We have done it for Bessel's function. Okay, we have already seen it. So we are going to check for Legendre polynomial. What are the recurrence relation that we should know? See, as a student, the tragedy is you tend to you need to remember all of these. Okay, maybe for this exam purpose you need to remember minimum of them. But if you are appearing for entrance and all, these recurrence relations should be something which should be there. Okay, in your head. That's very important. But for exam purpose also you need to do it. And if I'm asking you a question from this particular unit, there are so many topics that you need to know. Becomes a bit challenging. I understand that, and that's why you have to do your studies you know in an organized way. That's very important. If you're organized, I don't think it will be very difficult. So make your notes properly, make some lists, and then try to put it in front of your study desk. Have a look into it every now and then. Okay, then eventually you should be able to remember all of them. So as I'm writing, I hope that you are also writing it. Okay, this is the second relation. Pn plus 1 is equal to 2n plus 1 into x p n minus n p n minus 1 n is greater than equal to 1. Okay, and then there is one more. C, this is x p n is equal to n plus 1 divided by 2n plus 1 p times n plus 1 plus n divided by 2n plus 1 into pn minus 1. Okay, so if you look into these three recurrence relations, this is x. If you look into these three recurrence relation, what we are going to do is we are going to derive this, and we are going to see that the other two, a and c, are can be derived from b. C straight away is visible. See, this is xpn, you divide throughout by 2n plus 1, you get the relation. Very simple. Okay, C to matlab ek hi hai, just adjustment, that's it. Just look into B. Okay, let's just try deriving this. Let's start. Okay, so we are talking about Legendre polynomial and we are deriving the recurrence relation. It means that we have to start with some function, and that is our generating function. So we'll start with 1 minus 2xz plus z square whole thing to the power minus of half. Okay, is equal to summation n is equal to 0 to infinity z to the power n p n x. Okay, so that's there, and then what we are going to do is differentiate with these steps. You need to remember. I'll tell you how this is used on both sides with respect to z on both sides. So check this. This is n minus 1. So you have the power of z to the power n, p and x. So you need an n in front here. So that means if you differentiate it, you get that n, right? So that way we can actually remember that yes, we have to differentiate it. Just carefully look into the problem, and that should give you a lot of hints on how to do it. So I'm just differentiating with respect to z. Let's do it on the left hand side. So minus half into 1 minus 2xz plus z square. We have done it in the last class also yesterday. Minus of 3 by 2 into, then you differentiate this would be minus of 2x because we are differentiating with respect to z plus 2z, right? That's it on this side. On this side it would be summation n is equal to 0 to infinity n z to the power n minus 1 p n x, right? We have it here. So we're just going to simplify this. So if we just look into this left hand side, this 2, and you can take out 2 common here, okay, and then you can take out the minus sign. This will be x minus z, that 2 will get cancelled. So I'm just writing it down directly. I hope you understand. It's very simple algebra here. X minus z into 1 minus 2x z plus z square whole thing to the power minus of 3 by 2. That's there on left hand side. Okay, and on the right hand side we have the same thing, right? Nothing changes on right hand side. N z to the power n minus 1 p n x z is equal to 0 to infinity. Okay, so we have it here. And then what we do is, let's check what we need. So we need one pn here, and it is to the power 3 minus 3 by 2. So this is not pn, right? For this to be pn, this should be minus of half. So a simple way would be to multiply both sides. Okay, multiply both sides. There should be logic. Okay, mathematical physics, I have seen that if you know the logic, if you know the steps, then it becomes easier to remember. Why I want to do this, that is very important. Always ask this. Plus z square. So I multiply both sides with this term. So if you multiply it on this side, this is x minus z, and this would be multiplied, that means minus 3 by 2 plus 1, this is same, plus 1. So this would be 1 minus 2xz plus z square to the power minus of half is equal to, I will take it outside the summation, xz plus z square multiply summation n z to the power n minus 1 p n x. Done. Now what we can do is, we can obviously simplify things. I can take this x minus z, and what is this? See, 1 minus 2xz to the, well, this is nothing but this term, right? So that means this term can be written as, don't lose track, n is equal to 0 to infinity z to the power n p n x. Okay, this there is equal to, now what we can do is, okay, let me just repeat this, 2xz plus z square summation n z n minus 1 p n x. Keep doing and we should actually get the result. Okay, I'll separate it out. So first term would be x summation z to the power n p n x. Write down n is equal to 0 to infinity. I'm not just writing it down. Okay, minus, this would be summation, this is z to the power n, this is z, so it will be z to the power n plus 1. So I can write it down as z to the power n plus 1 p n x. Okay, done with this side. On the other side we can again do the same thing here. Let's try modifying, or maybe expanding, z to the power n minus 1 p n x. Then this is minus of 2x, this 2x, and there is a z, so I'll take it inside. So if I take it that way, this would be n, this is z to the power n minus 1, there is a z here, so n minus 1 plus 1, it will become n z to the power n p n x. Done with the second term. Let's do the third term, and third term also the same thing. This would be summation n z to the power minus 1 plus 2, so n plus 1 p n x. That's it. Okay, so we have it now, and then what we can do is we can just do certain modifications, and after that we should be able to get the answer. So last class also we have seen that what we did was equate coefficients of z and n on both sides. Today also we are going to do the same thing. Okay, so let me just copy it to the next page. I don't want to rush with it. Okay,
Excuse me, sir.
mathematical physics. Yeah,
Sir,
tell
from
me.
where you have started today? Sir, actually, I have joined now.
This one. This is the first slide. Okay, you can note it later. Okay, if
Okay.
join now, so I cannot repeat that entire slide, but
No,
don't
sir.
worry,
No.
it's okay. Okay, do it, just wait. क्या हो रहा है? Okay, anyway, have to not got copied here. So we are talking about the recurrence relation of Legendre polynomials. So we have it now, and then what we can do is equate the coefficient of Zn on both sides. So equate coefficient of Zn. Okay. So if we equate the coefficients, let's see what we get. On this side it is x p n x first term minus, this is the n z to the power n. That means if I want to take z to the power n, in place of n I should put n minus 1. That will be the n minus 1 term plus 1. So n minus 1 plus 1, it will become z to the power n. So that means this will become n minus 1. So that means this is p n minus 1. Understand the logic, okay? I'm not expanding it, but I think it's quite logical. You should understand this. Next, we have got here z to the power n minus 1. I need coefficient of n. So that means if I put in place of n, I put n plus 1, I will get this as z to the power n. So if this is n plus 1, this should also be n plus 1, this should also be n plus 1, right? So here I should put n plus 1. So if I take it, this would be n plus 1, this will become n plus 1 into p n plus 1 x. Next term minus z to the power n, no confusion here, this is 2 times x n p n x. This is there. Here in place of n I should write down n minus 1. So this will be n minus 1, this will be n minus 1. So this will be n minus 1 p n x. That's it. Okay, it's very simple now. Let's just combine, this is pn. Let's see if there are any other pn. Yes, this is a pn here. Okay, let's just combine these two terms. So we can just take x within bracket, it will be 1 pn, I'll take it out. Okay, and this side we have got 2x and I've already taken common. So 1 plus 2x into pn. Why plus? Because this is minus on this side, so I'll just take it on this side, so it'll be plus, right? And then what I can do is there is a minus here, so I'll take this minus, and let's see what we have in store. We have got pn minus 1, and we have got okay, this one also I think I've written it by mistake. This should be n minus 1, right? So check these two terms. Okay, this is uh, pn minus 1 minus of pn minus 1, right? This is minus of pn minus 1, and this will go on the other side, so this will be again minus npn minus 1. I'll open the bracket, this is minus, and this will go on the other side, so this will become plus pn minus 1. So these two will get cancelled, I'll be left out with npn minus 1, right? So I'll just write it down directly here, n p n minus 1. So these two terms also I have combined. Okay, next we are left out with this, so let me just write it down on this side only, n plus 1 p n plus 1 x. Okay, or others also x are there. So what is the term that I need? Okay, let's just check back. What is my relation? This is my relation. So I need n plus 1 p n plus 1 on one side, and see what we get on the other side. So let's do it. So we have got n plus 1 p n plus 1 on this side, right? So I think we have already derived it. Let me just write it down correctly. N plus 1 p n plus 1, done with the left hand side. On the right hand side, if we check, let's see if it's correct. Yeah, this is 2n plus 1 x p n minus n p n minus 1. So see, we're getting the term. So we're getting the term. So I'll just arrange it that way. So it will be 1 plus 2x n p n minus n p n minus 1, right? So this is relation B. proved, right? Got relation B. That's it with relation B. Okay. We can also derive the other relations from relation B. As I said, it's actually simple. Let's do it. Okay. So what you can do is, okay, let me just derive it and then I can discuss it a little better. So divide by 1 plus 2n. So you have to divide by 1 plus 2n on both sides. Okay. And in that way we can actually get the simpler form of this. Okay. Sorry, 1 not 1 plus 2n, 1 plus 2x. So therefore we can have this npn. Okay, npn 1 plus 2x on one side, so I'll just simply write it down as npn on one
So on
side
the right hand
is,
side, hello sir.
yeah, tell me.
So in the right hand side, it will be 1 plus 2n into x naught.
Or let me
So
just
that
check
was
here.
2n.
This was 2n, right?
Yeah.
Let me check. I think I miswrote it somewhere. I have taken x common, right? Absolutely,
Yes, sir. X common.
yeah, यहाँ पे गड़बड़
1
हो गया.
plus 2n.
This is 2n. Oh yeah, this is a mistake here. Thank you. Okay, so this is x, this is n, correct. That's why I was thinking we divided by 2n. Yeah, so this will be divided by 1 plus 2n on both sides. Okay, so divided by 1 plus 2n on both sides, then we should, I think, get it. Yeah, correct. So I can have xpn on one side, so I'll take this as x. This is not n, this is xpn on one side, and on the other side I can have it as n plus 1 divided by 1 plus 2n. This is pn plus 1, then minus will become plus because I'll take it on this side. This will be n divided by 1 plus 2n pn minus 1, right? So this is our relation C. As I said, relation C, simple. So the relation, you have to remember only one. If you remember the relation B, other things will be easily proved. Done with relation B. Okay, and then we have got relation C. In relation C is also not very difficult. See here, sorry, relation A. If we check with relation B, this is npn, this is 2n minus 1, this is n minus 1. We have got n here, this is n minus 2. That means everywhere, if you see, if you replace this n with n minus 1, you are going to get relation A now. Okay, let's do it and I think it will be more clear. Let me take relation B and then we will do it there. Okay, so this is my relation B. Already have it. ना लंबा लेके फायदा नहीं, यही तक लेते हैं. This is my relation B. Take the page. So we can use relation B, let's see, and we can get relation A from relation B. Thus this is relation B, we'll put n is equal to n minus 1. See, this is a recurrence relation. So there is a series of terms here. So whatever may be the relation between the n's, the same will be the relation between n minus 1 and n minus 2 and so on. Okay, so you can always put n is equal to n minus 1, but then you have to put it uniformly, you have to put everywhere. That's very important. So in here, if I put n is equal to n minus 1, I will get n p n. N ki jagah n minus 1, 1 will get cancelled and we get this. What about this? This is nothing but 2n minus 1, that means 2n minus 2, and then there is a plus 1. 2n minus 2 plus 1, and x will be there, and in place of n it will be n minus 1. Minus, in place of n it is n minus 1, and this is p, in place of n it is n minus 1, so this is n minus 2. So if we do it, this would be nothing but 2n minus 1 x pn minus 1 minus n minus 1 pn minus 2. Okay, frankly I don't remember what was the relation a, but I think this is correct. ठीक है, देखते हैं. Yeah, so npn 2n minus 1 x pn minus 1 minus n minus 1 pn minus 2. That's correct. Okay, so this is your relation a proof. So you see, this is easy. You have to just know one relation and that's it. You can actually prove the other. Relation a proved. Okay, so a very simple thing is here is the simple question, that might come to your mind, that I'm asking you to prove this. I'm not asking you to prove all three in exam, or I'm asking you to prove this. For any of these relation, if you want to prove, you have to start from here only, because this is a descriptive question. Okay, if I'm asking you a 2 mark question, I might say given is this, prove this, but then this is very simple, so I might not even ask this question. Okay, so even if I ask you prove a, b or c or all three of them, you have to do all the steps. That's very important. Okay, this is a descriptive question, so you have to, even if I ask you prove a, start from here, go up to a and prove it. That's it. Okay, in the middle you need to skip this. You don't need to write this because you are not asked to prove b. Sorry, relation C, relation A. So यहाँ तक लिखो, then just prove it. That's it. ठीक है, that's important. Okay, let me take one more recurrence relation here. Let me take a new board. Okay. So sometimes I don't consider them as a question which is in theorems or theory. It's actually a numerical problem that you have to basically prove. So you can take it as a question only to prove. Although this is also a part of recurrence relation. NPN x is there, of course. Even if I don't write down x, please make sure know that it's there. Okay. NPN dash minus pn minus 1 dash. Okay, that's it. So this also we have to prove. So if we want to prove, we have to start with the generating function. So this is 1 minus 2 xz plus z square whole thing to the power minus half is equal to summation n is equal to 0 to infinity z to the power n pn. Okay, that's it. I don't write down x here. So npn, and you have to take a dash here, so that means you have to basically differentiate, right? So let's just differentiate on both sides. Okay, the question is with respect to what? So with respect to z, let's just differentiate it with respect to z first. Okay, and if we do it, this will be minus half, or maybe I can directly write it down. I've done it in the previous step. So x minus z, this is 1 minus 2xz plus z square. You know how we get it, minus of 3 by 2. Differentiate it, you'll get it. Is equal to summation n is equal to 0 to infinity. It's the same. N z to the power n minus 1 p n. That's it. Let's mark this as E. Okay, mark this as E. Okay, now what we want to do is we have to get a pn dash term also, and pn is a function of x. So that means it's obvious that we have to differentiate with respect to x as well on both sides. Okay, so if we differentiate it with respect to x, it will be, okay, we have not done it before, so let me just do in detail. 1 minus 2 xz plus z square whole thing to the power minus of 3 by 2. With respect to x means I have to ddx of this, so ddx of this would be nothing but minus of 2x, right, is equal to, not 2x, 2z, sorry, x to variable है यहाँ पे, 2z, right, is equal to summation, differentiating with respect to x, so that means z to the power n is remaining intact, and this will become pn dash. So I'll just write it as pn dash. Okay, so here what we can do is this minus minus will go out, z 2 will get cancelled. I'll just have z 1 minus 2 x z plus z square whole thing to the power minus of 3 by 2 is equal to summation z to the power n pn dash. Okay, now you see we need this. In on this side it should be x, this is actually z to the power n. Okay, a trick which you should, this is kind of, you should remember. Once you do it, you will realize that yes, this is something which you need to do. Multiply minus z on both sides. Now you know why x minus z, because here you have got an x minus z and you've got this term. So actually you can use it. Okay, we can use this term. Second. So let's just multiply by x minus z on both sides. If we do it, it will be z, and this would be x minus z, and then 1 minus 2xz plus z square minus of 3 by 2 is equal to, this side we can actually expand, but we will expand it later. Now be x minus z, z to the power n pn. Yes. Okay, that's it. Okay, let's use a. Okay, using a. So what is my a? My a is this, x minus z into this is this. Okay, so that means I can write down z, z ki jagah z rahega, and then this entire term will be replaced by this, right? So I can write it down as summation n z to the power n minus 1 pn, okay, is equal to, I will just separate it out. I'll take two terms here, x summation z to the power n pn dash minus, now this can be written as z to the power n, it is z to the power n plus 1 because z के साथ multiply हो रहा है. So this is pn dash, that's it. Okay, and what else we can do? Let's see, we need this relation, right? npn. So where we have npn here, this is the npn, and there is a z here. Okay, so this z will get multiplied with this, so I'll be getting z into z n minus 1, so z to the power n. Okay, so yes, so that means we can just write it down as summation z n pn is equal to x, I'll take it out. This is also z to the power n, this is pn dash minus summation, this is just leave it like this. Okay, now check, the technique. Now we have to equate the coefficient of z, equating z to the power n coefficients, right? So z to the z to the power n either. So this is n, this is z to the power n, so this is x pn dash minus, if I want to write it down as z to the power n, this n should be replaced and written as n minus 1, so this is n minus 1 plus 1 will become z to the power n, so this should also be n minus 1, so this will be p n minus 1 dash. आ गया अपना? हाँ, आ गया. So we'll got the relation, right? So this is how we prove it. Recurrence relation, correct. Proved. Okay, so orthogonal property is important. हो गया. Okay, so I think it's a good point to stop. I want to take up another problem, but then I think it's okay if we can take it up in the next class. Okay. So this is the recurrence relation. In the next class, the topic is actually a bit long. We are going to look into the orthogonal property of Legendre polynomial.